Hello, welcome everyone. Welcome back to my channel. We were doing circle theorems and we have seen few. Let me do some questions on those circle theorems that we have already done and let me revise them quickly. Here is a theorem 1 which says angle at the center is always twice at the circumference. And we have done its proof. I have explained it, and this is the first question. It says if angle ACB is 30 degrees, then we have to find angle AOB. So obviously applying the first theorem which says angle at the center, which is this one, is twice at the circumference. That means circumference, that angle is 30. So this angle is going to be twice of it, which will be 60 degrees. And always you have to give the reasons, especially in geometrical proofs you have to. Moving on to the theorem 2, it says angles in the same segment theorem, and angles those are in the same segments are always equal if it's subtended by the same arc. Then this was the proof that we did. The theorem 3 was angle in a semicircle, which says that angle in a semicircle, because this is a semicircle, so angle in a semicircle is always 90 degrees. Now we have done its proof as well. If we see question, so question says calculate the angle ADB if angle ACB is 40 degrees. That means this angle is already given as 40 degrees, this one. This is. So our solution says given angle ACB is equals to 40 degrees, then angle ADB that they are asking is also 40 degree by angle in the same segment. And it would be better if we'll write the complete statement of angle in the same segment, which says that angles of the circle in the same segment are always equal. Moving on to the next question. It says in the diagram above, O is the center of the circle, then find the angle CBA. That means this angle we have to calculate if angle CAB is twice the angle of CBA. That means angle CAB is twice of angle CBA. So let me assume angle CBA be x. That means this be x. So if this is x, then this is going to be 2x definitely, because it's already mentioned here. So angle CBA is x, then angle CAB will be 2x. And we know that angle ACB is going to be 90 degrees because angle in a semicircle is always 90 degrees. So angle in a semicircle is always 90 degrees. So by angle sum property, I'll say x plus 2x plus 90 is equals to 180. So 3x is equals to 90 and x is equals to 30 degrees. So we have to find angle CBA, which is 30 degrees here. Now let me move on to the next theorem that we haven't done in our previous video. It's first we have to understand what is cyclic quadrilateral. A cyclic quadrilateral is any four-sided quadrilateral, but important part is it's inscribed in a circle. All the vertices of this quadrilateral lies on the circumference of a circle. You can clearly see that A, B, C, D, all the 4 points are lying on the circumference of a circle, and hence it's called cyclic quadrilateral. There is an important property of a cyclic quadrilateral, and that is your theorem 4. So theorem 4 says, this is a cyclic quadrilateral theorem. It says the opposite angles of a cyclic quadrilaterals always add up to 180 degrees. So which means these two they have to be opposite in nature. So this one, you can see here, this one and this one are clearly the opposite angle. When you add them up, it will give you 180 degrees. Similarly, angle B, this one, and angle D, this one, is 90 degree, is the opposite angle, and when you add them together, it will give you 180 degrees. So now this is a cyclic quadrilateral, and we have to prove that the opposite angles add up to 180 degrees. So I'm taking this bx, let's say this bx and this by. And we have to prove that x plus y should be equals to 180 degrees. Now, we know this arc BD, this complete arc BD is subtending angle x. So this arc is making x angle at the circumference, and this is the angle that it's making at the center. That means this angle is making at the center. So if this is x, then this is going to be 2x. This is 2x. So I can write that since angle BCD is x, angle BOD will be 2x by the same, that is angle at the center is twice at the circumference. Now similarly, if I say this be angle y, which is here, this is angle y, so this arc is subtending this angle here. So at the center, the same arc is making this angle at the center. That means this angle will be 2y. So I can say that we know angle BAD is y, then angle BOT will be 2y with same, that is angle at the center is twice at circumference. Now this will become 2y. We know if I add this complete circle 2x plus 2y, this will give, so 2x plus 2y, so this 2x plus 2y will be equals to 360 degrees. Dividing both the sides by 2, I'll get x plus y is equals to 180 degrees, and hence we have proved that the opposite angle add up to 180 degrees. Now let me do one question on this theorem. Now see this question. It says on the figure given above, calculate the value of angle CBA. CBA, that means this angle they are asking you to find. Clearly, first you have to check whether the quadrilateral is a cyclic quadrilateral or not. Clearly it is, because all the vertices are lying on the circumference of the circle. The next is applying the circle theorem, which says that opposite angles always add up to 180 degrees, which means angle D, so our solution says angle D plus angle B is equals to 180 degrees, because opposite angles of a cyclic quadrilateral always add up to 180 degrees. So that means if they are 180 degrees, so angle B will be 180 minus 70, which is 110 degrees. Moving on to our next theorem, which is perpendicular from center to a chord. Well, first of all, a chord is a line segment that touches at 2 points, and that is inscribed inside a circle, obviously, and this is called chord. The longest chord of a circle is diameter. Now it says if you are dropping a perpendicular from the center to the chord, this is clearly center, and you're dropping a perpendicular from the center to the chord. This AB is the chord, and if this is perpendicular, most important, you are dropping a perpendicular, then it will always bisect the chord. Bisects the chord, that means it will divide the chord into two equal halves. So say for example, if this is 2 centimeters, this will also be 2 centimeters. Or if I say this whole will be 6 centimeters, then each one will be divided into 3 centimeters because it's been bisected by the straight line dropped from the center of the circle, but it has to be perpendicular. So you can see that this statement says the perpendicular from the center to a chord of a circle always bisects the chord. Let me see its proof. Well, the same, we have already drawn the chord and the straight line. Now to understand it better, let me just join these two ends, and similarly let me join these two ends. Let me just draw it more properly like this. So if I say I have divided this into two triangles, what I'm trying to do, because this side is part of the left triangle and this side is the part of right triangle, if I'll be able to prove that the given two triangles are congruent triangles, then it would be easy for me to prove that they both are equal. Let me just name this one BC. Let's say this BC. So now the proof says, let me join OA and OB. Then we will have two triangles. Triangle AOC, which is this left one, and then triangle OCB, which is basically your right one. Now, comparing that, this is triangle AOC and this is triangle OCB. In triangle AOC, this is 90 degrees and this is 90 degrees clearly. So I can say angle ACO is equals to angle OCB is equals to 90 degrees because angle that is already mentioned, obviously, right? Because according to the theorem, that is already mentioned. So more specifically, I can say that is given. Then OA is equals to OB is equals to radius. So this is equals to this one, and they both are clearly the radius. Radius is what? Any straight line that connects the center to any point on the circumference of a circle. So this is radius. Now the third one is OC is equals to CO. This is a common chord in both. You can say a common line segment. This one, OC, and it's a part of both the triangles. So I can say OC is equals to CO common line. And if these two are common line, then I can prove that by right hypotenuse side, that is by RHS, these two triangles are congruent. And if they are congruent, that means all the corresponding sides and angles are equal. That's the meaning of congruent figure or congruent triangle. So I can say hence AC is equals to CB, which proves the theorem, because theorem says that this will be bisected, and bisection means AC is equals to CB. So this proves the theorem. Now the next theorem deals with the tangent. So first of all, let me understand what tangent is. So tangent is a straight line that touches a curve, not necessarily only to a circle, to any curve. Obviously a circle is also, so we can say a curve or a circle. If it touches at a single point, then it's called a tangent. Theorem 6, the next theorem, as I told you, it deals with the tangent. So it says the angle between a tangent and a radius is always 90 degrees. So this is about theorems. Theorem 7 and Theorem 8 we'll be discussing in the next class. They're very important, so don't skip the video. Also, if you're looking for the booster, the crash course classes for GCSEs for all subjects, you can just drop us an email. Also, we are running the regular classes. GCSE classes are just £6 per hour, and classes from year 1 to year 13 are really at affordable prices. If you're looking for test series, we are running the test series starting from the 22nd April. You can enroll for it. They are also highly you can say affordable. And also, if you are looking for mock papers or the quick revision sheets or the flashcards, you can purchase from here at highly discounted rate. All you just need to do is to just drop us an email at exactacademy@gmail.com. And also you can book free demos. Even you will be able to find some free sample papers before you purchase. Obviously, it's we can't just let you purchase without giving you any sort of demo. And if you are looking for free worksheets and as well as free theory sheets, they are available at our website, which is www.exactacademy.com. So that's it for today. Bye everyone. Take care.